presenting data. So far we have used the print statement to format the output. Now we will see 3 more features of the Perl to format the output: Printf function, HereDoc documents, format and write functions. Printf function. The Printf function is like the print function, but with extra features that allow you to specify how certain data is printed out. Perl's Printf function is taken from the C language function of the same name. Here is an example of a Printf statement. My $first equal to 3.14159265 and my $second equal to 76. My $third equal to hello world. Remember that all the variables start with $symbol. Then the Printf statement, printf stdout a float 0.6.4f, an integer percentage minus $5d and a string percentage %s /n, $first, $second and $third. The output produced by this code looks like a float 3.1416, an integer 76 and a string hello world. The arguments to the Printf function consist of a format string followed by a list of values that are printed as specified by the format string. The format string may also contain any text along with the directives to print the list of values. The directives consist of a percentage sign followed by a required conversion specifier, which is in the example include F for floating point, D for integer and S for string. The conversion specifier indicates what kind of data is in the variable to be printed. Between the percentage and the conversion specifier, there may be 0 or more flags, an optional minimum field width, an optional precision and an optional length modifier. The list of values following the format string must contain data that matches the types of directives in order. There are many possible options for these flags and specifiers. For example, the directive %6.4f specifies to print a floating point, that is a decimal number with a minimum width of 6 characters overall and at most 4 positions for the decimal part. You see in the output that although the $first floating point number gives the value of pi to 8 decimal places, the example specifies a precision of 4 decimal places, which are all that is printed out. The percentage minus $5d directive specifies an integer to be printed in a field of width 5. The hyphen flag causes the number to be left justified in the field. Here documents. Here documents are convenient ways to specify multi-line text for output with perhaps some variables to be interpolated in a way that looks the same in your code as it will in the output, that is without a lot of print statements or embedded new line, that is /n characters. We will see an example. Here the variable DNA is initialized with a string. Next you can see a for loop to print the DNA sequence. It has $i equals 0 as initialized value and $i less than 2 is the condition, and it is modified with 1 each time. Then print here doc on iteration $i of the loop $DNA ends with here doc and then exit. The output may look like the one given on the screen. In this program, a here document was put in a for loop so that you can see the $i variable changing in the printout. The variables are interpolated into a here document in the same way they are interpolated into a double quoted string. Every time they go through the loop, the contents of the here document are subject to variable interpolation and are printed out. The terminating string used in this example here doc can be any string you specify. Here documents are handy for some tasks, such as when you have a long multi-line document with just a few changes applied each time you print it. For instance, a business form letter with only the addressee changed. Using a here document preserves the look of the final output in the code while allowing variable interpolation. Format and write functions. Format is designed to generate reports and can handle page numbers, headers and various layout options such as centering and left and right justification. It is modeled on the Fortran programming language conventions for formatting and so is particularly handy for producing reports based on that style, such as the PDB file format in which fields are specified as occupying certain columns on the line. Here is an example program of a format that creates a FASTA style output. After declaring and initializing the variables that fill in the form is defined with format stdout equal to and the format continues until it reaches the line with a period at the beginning. The format is composed of three kinds of lines: a comment beginning with the pound symbol, a picture line that specifies the layout of text, an argument line that names the variables that fill in the preceding picture line. The picture line and the argument line must be adjacent. They can't be separated by a comment line, for instance. The first picture line or argument line combo is for the header information. The picture line has two picture fields in it associated with the variables $ID and $description respectively. The picture line begins with a greater than sign, which is just text that begins each FASTA file header line by definition. Then comes the first picture field, which is an @ sign followed by 9 less than symbols. The @ sign declares a field that has the associated variable interpolated into it. The use of the 9 less than sign specifies that the value should be left justified for a total of 10 columns. If the value is bigger than 10 columns, it is truncated. A less than sign left justifies, a greater than sign right justifies, and a vertical bar centers the data in the field. The second picture field is almost identical. It is longer and ends with 3 dots, which prints if the contents of the variable $description can't fit into the length of the picture field. The next pair of picture or argument lines is shown on the screen. The picture field starts with a caret, which declares a picture field that will handle variable length records. The line also contains 49 less than signs for a total of 50 columns left justified. At the end, there are 2 tilde signs which indicate there should be additional lines for the data if it doesn't fit one on one line. The write command simply prints the previously defined format. By default, the output goes to stdout as is done in the example.